Hello everyone. Previously we had discussed on the topic Z algorithm, right? So Z or Z algorithm. So today we'll be discussing on the topic Manacher's algo, also called as Manacher's this one string algorithm, right? String processing algorithm basically, right? So this they would teach this one in the colleges, I believe. Some of the important string algorithms, this Robin Karp algorithm, this Manacher's algo, and some of the graph algorithms. These are taught in the colleges as well, I believe. So let's try to understand the same. Let's get into the definition part first. So, Manacher's algorithm is an efficient algorithm to find the longest palindromic substring, where it is used to find the longest palindromic substring, right, in a given string. Again, so this part is very important. I'm stressing on it. If you don't know this itself where to implement, you'll not be able to implement this one, right? So, Manacher's algorithm is an efficient algorithm to find the longest palindromic substring. Many of the lead code questions and the CP questions where you are finding the longest palindromic substring, right? So where you want to find the longest palindromic substring instead of going with a brute force or this one, which will lead to like checking with every other substring. So you can just go with a Manacher's algorithm. So let's see the same thing, right? Manacher's algorithm is an efficient algorithm to find the longest palindromic substring in a given string. It runs on big O of n time. Again, what would be the time here or the time complexity? It runs in big of n time, right? So making it much faster than nav this one big of n square or the dynamic programming approach. So that's what I said, right? So it would take big of n square because you have to check with all other this one substring, right? So which will lead to big of n square quite obviously, or dynamic programming approaches. So if you go with right, so basically this particular algorithm, with the help of this particular algorithm, we can this one find the longest palindromic substring and big of n time, right? So basically this algorithm is used to find the longest palindromic substring within a given string, with a given string. Just remember this one, man, right? So let's get into the explanation part and let's try to implement the same thing whatever we discuss in the this one explanation part, right? So let's start. So first thing here, this one. So a palindrome is a string that reads the same forwards and backwards, right? So this one we know. Still, let me tell you this one. What is a palindrome? First, let's go step by step. We have time, right? So I'll just give you a palindrome. This is one simple example of the palindrome, ma'am. In the simple terms, it reads the forward and backward same. Means it reads the same forward and backward. So MAM, ma'am, from this one is from forward, and if you read from backwards, it is same MAM map. Same goes with see here example race car and ABA, right? So this is the simple example of the palindrome. Now, accordingly with the definition, a brute force approach checks every possible substring that would lead to big O of n square. We know this. I had stressed this one during the definition part as well, right? So the brute force approach checks every possible substring, nothing but it would lead to big O of n square. And what does the Manacher's algorithm do then? Manacher's algorithm improves this by using the previously computed palindrome lengths and symmetry to skip the redundant checking, to skip the redundant checks. Right? Again, Manacher's algorithm improves this by using previously computed palindrome lengths and symmetry to skip the redundant checks. So this part is very important. So let's see how it works, but how it improves. So this Manacher's algorithm basically improves this by using previously computed this one palindromic length or the palindrome lengths, right? So these four words, just remember when it comes to Manacher's algorithm, you have to remember this one. So this will improve the brute force by using previously computed palindrome lengths. That's it, main thing. And symmetry to skip the redundant checks. We have to skip the redundant checks, right? So no need of redundant checks, checking again and again. So this is fine. Now let's see the same thing in the action, how it works basically, right? So the first step here would be we will be transforming the string with separators. Separators in the sense hash I have written here, right? So we will be transforming the string with separators hash. So even and odd length palindromes can be handled uniformly, right? So again, first step is will be transforming the string with a separators. Simple, just keep this in mind, right? So let's see the same thing in the form of example here. Suppose if we are having ABBA, right? So this is a palindrome. So what we will do, we will be making use of the separator as I have said, right? So this one will be hash a, hash b again, hash a, and hash dollar. Dollar, this one are sentinels. This one will be added at the end, right? So this one, to the power of symbol, this one, whatever we have written here, this one and dollar are sentinels basically. Just remember this one. This will be added at the end. So this one will be hash a, hash b, hash b again, hash a again, hash dollar sentinels, which will be added at the end. Just keep this on mind, right? So this is fine. Now we will be maintaining an array p where p of I stores the radius of the palindrome centered at the position I, right? So we will be maintaining the array p where iterated value of the p stores the radius of palindrome centered at the position I. Simple, very simple, right? So now see, we will be making use of the two variables. One is C and another one is R. C is nothing but the center of the current palindrome. Again, so this one, if you understand now, while implementing this one in the form of code or while we write the algorithm, so you'll understand this one very quickly. So same thing we'll be articulating in the form of code or implementing in the form of code. Just see this one. See, we will be maintaining an array p where p of I stores the radius of the palindrome centered at the position I, as I've said. So C is nothing but the center of the current palindrome and R is nothing but the right boundary, right? Right boundary of the current palindrome, right? So this is fine. Now expanding the palindromes while reusing the results from mirror indices. So that's what we will be doing. This part will be seeing that one in the action while we write the algo, right? So total result will be the maximum value in p gives the length and position of the longest palindromic substring, right? So the maximum value in p, what it will give, it gives the length and position of the longest palindrome substring, right? I hope this part is completely clear, man. We are done with the Manacher's algorithm. Let's do one thing. Let's quickly write the algorithm based on the explanation, right? So we'll go step by step, right? So let's start. First, let me go with the function name Manacher or Manacher algorithm. Let me give Manacher. That's enough. So this is fine. Let me pass the parameter s, nothing but the string, right? So here the first step would be we have to transform the string, right? So here we have to go with the sentinel as well as this one to the power of or whatever the symbol that you call along with the hash, and we have to join that one to the string, right? This one hash along with the dollar. Also we have to include this one to the power of symbol as well. So accordingly with the this one, what do we call this one explanation part that we discussed, right? So this one, let me go with this along with the hash here. This is fine. Now let me concatenate or append this one here. This is fine. uh we have to include hash, so I'll just go with, we need to join, right? So join this one to the string s we have considered as parameter. This is fine. Now let me go with hash s, this one dollar, sorry, uh the end, at the end basically. This is fine. Now and let me assign this one to the length of the t. This is fine. Now let's move on with the second step. So what is our second step? We have to go with the array to store the palindrome, right? So palindrome radii, we have considered radius here. See here, maintaining an array p where p of I stores the radius of palindrome centered at the position I. So that's what we'll be doing now, right? So we will be maintaining the array to store the palindrome radii, right? So I'll just go with p here. So this one will be 0 into n. Simple. Again, let's go with the center and the right boundary. See this part. We'll be making use of the two variables as I've said. So C is nothing but the center of the current palindrome. R is nothing but the right boundary of the current palindrome. So let's go with the same here. So this one C. Now let me go with both. Let me initialize 0 to both. Right. So this is fine. Now let's move on with the further steps. We are done with the second step. So now what we need to do, we have to expand around the center, right? So what we need to do now, we have to expand around the center. This part, man, expanding palindromes while reusing the results from mirror indices, right? So we have to expand around the center. Let's see how we can do the same, right? So let me make use of the for loop here. So this one for I in, let me go with the range ranges from 1 to n minus 1. So this is fine. Now within the for loop, what we need to do, let's go with a mirror index with respect to the center C. When I say mirror index with the respect to center C, I'll just go with mirror. Let me assign this one to 2 into C minus I or hyphen I. This is fine. Now let me do one thing. If I is less than R, so if I is less than R, then uh, iterated value of the P equals min of R minus I, comma, this will be P of mirror. I have to pass mirror here, right? So we are just going with a mirror index with respect to the center C, expanding palindrome while reusing the results from the mirror indices. Again, what we are making use of here, basically, we are going with a mirror index with respect to center C. I have written simple if condition as well. I hope this part is completely clear, man. Next, so why this is giving us error here? What is this? P is not defined. So did I give small p here? Yeah, this is fine, man. Now, let me do one thing. Let me go with a simple while loop. Why? Because we have to expand the palindrome centered at the I. Right? So let's try to expand palindrome centered that is centered at I. So let me go with simple while loop here. So this one will be while t of I plus 1 plus iterated value of the p. This is fine. So this is equivalent to t of I minus 1 minus iterated value of the p. So this one will be iterated value of the p equals iterated value of the p plus 1, right? So now again this p has to be capital man. This is fine. Now we are done with this part. Sorry. Yeah, we have successfully expanded the palindrome that is centered at the I, right? So now accordingly with the next step, this one approach that we discussed, or this one explanation part. So if the palindrome expanded is beyond goes beyond R, then we have to adjust C and R, right? So then we have to adjust C and R. So that let's do that within the simple if condition. If I plus, so this is boundary condition basically. So this is fine. P of I, if it is greater than R, so then what we will do? So we will be going with C, comma, R. Let me assign this one to the I, along with I plus this one will be P of I. So this is fine. Now I hope this part is completely clear, man. Let's do one thing. Let's go with the final step, or this one, what do we call, not the final step basically, uh fourth step. So we have to find the longest palindromic length and the center, right? So let me do one thing. Let's go with the variable name max length, and I'll just go with this is equivalent to the max. Let me pass p here. P, this has to be capital again. So this one I forgot this one multiple times, right? So this is fine, man. So I'll just go with the center index. So this is fine. Again, I'll just go with a p dot index here. Let me pass maximum length. So max length, this one. This is fine. Now let's go with the step 5. See here, we have to extract from the original string, as I've said, right? So when I said we have to extract from the original string, so let me assign start. So this one start to this one center index, whatever I have given the variable name, minus. So this will be max length. I have made use of max length, right? So this one by 2. This is fine. Now again, we have to return this one s of start, from start to the max length, right? So from start, so this one, let's start from start to uh, max length. So I'll just go with the max length. We are appending or concatenating the max length. This is fine. We are done with the algorithm. So this is it for the algorithm. We exactly implemented the same thing that I explained earlier, or we went with the explanation earlier, right? We discussed the explanation part here, this part. So we exactly did the same thing. Yeah, we exactly did the same thing within the code or within the algorithm that we have written now. This is fine. Now let's do one thing. Let's go with the example usage of the test case. So now this will be, let me pass some random string man. So I'll just go with BA something D. This is fine. Now let's print the output for the interactive purpose. So I'll just go with longest. So this one will be palindromic. This one substring, longest palindromic substring. So this is fine. Now this one will be Manacher. This is fine. Manacher of S. So yep. This is fine. Now we are done with the coding part, right? So what is the output that we need to get here? This one. Basically, the output that we need to get here is longest palindromic substring. This one, BAB basically, right? So this is the longest palindromic substring that we need to get. Right, so BAB is a palindrome, and this is the longest palindromic substring within the BAB AD, right? So the output that we need to get here is longest palindromic substring BAB. So before running the code, let me explain certain things to you again, so that we don't forget the things, right? So here t equals this one, whatever I have written in the line number 31. So what we are doing here, we are just uh, transform this particular this thing, example accordingly. With the example I'll explain. So BABAD, right? So this one we will be transforming to this one, hash b hash a hash b hash a hash d hash dollar, for the uniformity, right? So this one we had discussed this one within the example here as well, right? So I said the same thing. So p equals 0, this one into n, whatever I have written. So this creates the array to store the palindromic radii, or the palindrome radius at each index, right? Accordingly with the algo. So c comma r 0 0, we are initializing the center and right boundary. We know this one, right? So just give me a second, 1 second. So we have initialized center C and the right boundary R successfully. We are done with this part, and now we are looping over each index I here. So this one, line number 37 I'm speaking of. So why we are looping over this one? We have to ignore the sentinels basically. So the dollars are the power to symbol, this one, whatever I have added, right? So we will be finding the mirror position, nothing but mirror into 2 into C, whatever I have given here. This one mirror equals, sorry, 2 into C minus I. This one. So now we'll be finding the mirror position. Also, if I less than R, we will initialize this one, P of I, this one, this part, and we will try to expand the palindrome around I by comparing the characters. So that's what we did, right? So next step is, if palindrome goes beyond R, nothing but the this one. Bounds, right? So this is related to the boundary check basically. If the palindrome goes beyond R, then we have to update C and R, right? So finally, if we will be finding the maximum value in P, nothing but the longest palindrome, palindromic radii, or longest palindrome radius. So finally, what we'll do, we will convert the index back to the original string and return the substring, right? See here, we have given longest palindromic substring. So this one, sorry, this one, start from start plus max length. Max length. What we are doing here, we are converting index back to the original string, and we will be returning the, or we are returning the substring, right? So according to this one. So this is fine. Now we are done with the algorithm part. Let's try to run the code. Let me give control J here. Let me type Python. Let me right click here. Let me copy this one, paste it over here, .py. So we have got the error here. Name P is not defined. Again, capital P. Line number 43 and 56. Yeah, this one 43, this has to be capital P, and here also this has to be capital P, and 56 we don't have anything, man. See, let me give clear screen here. Let me run this one again. So yeah, now we are getting the longest palindromic substring BAB, right? So this is a palindrome. Basically, if we uh, read this one from the forward, this is BAB, and if we read this one from the backward, it is BAB itself, right? So this is a palindrome, and the longest palindromic substring that is present within the string BABAB, this one BABAD, sorry, is nothing but BAB, right? So we have got the desired output or the correct output basically, right? So this algorithm works absolutely correct, right? So this is fine now. So we are done with the what do we call the algorithm, Manacher's algorithm, or the string processing algorithm, Manacher's string processing algorithm. Mainly just keep this in mind. First of all, to implement this one, you know where to implement this, right? So this is basically used to find the longest palindromic substring within the given string. Just remember this. Again, I'm stressing on this. Manacher's algorithm is used to find the longest palindromic substring in a given string. Again, simple, right? So now we are done with this part, man, right? So here, see, accordingly with the output that we got, one more thing I want to mention here, we have uh, BAB here. We can go with ABA as well, right? So this is also the palindrome, which is of the length 3 here, right? So we are going with a basically longest palindromic substring, right? So here either we can go with the BAB or ABA, right? So both are palindromes of the length 3, we know. So first BAB appears here within the string, right? So that is the reason we are displaying BAB, right? So if you are displaying ABA, so if we are having multiple outputs and if you are displaying ABA, that is also correct. ABA is also palindrome here within the string. So this BAB comes first, so we are displaying BAB here. Don't get confused. And yes, ABA is also the longest palindrome. That is also the right answer here, right? Accordingly with the algorithm that we have written, right? So don't get confused, right? So this is fine now. Now we are done with the Manacher's algorithm. Let's quickly get into the summary part, or let me summarize whatever we have learned so far. Just keep these things in the mind, whatever I say. There are some 4 to 5 points I just wanted to discuss with you guys, so just keep these 4 to 5 things in the mind, right? So basically, again, I'm stressing this, I have said this one multiple times. You have to know where to implement this particular algorithm. So this is used to find the longest palindromic substring. This is important, right? So the next step is this will instead of going with the naive complexity or the straightforward complexity, this one big of n square, nothing but the brute force, we can make use of the Manacher's algorithm, right? Manacher's algorithm. So the complexity would lead to big of n rather than the big of n square, right? So if you are making use of the DP or other approach, so then also it will lead to this one. You cannot come to the big of n basically, right? So in this case, by making use of the Manacher's algorithm, the time complexity would lead to big of n1. Just keep this in mind, right? Again, so this is used to find the longest palindromic substring. Instead of the naive complexity big of n square, we can make use of the Manacher's algorithm complexity that would lead to big of n, right? Now, what's the key idea? So basically what we are doing here, we have already written the algorithm and also we have discussed this one explanation part. So what's the key idea here? We are just transforming the string with separators, right? Separators hash, nothing but the hash. And also we are making use of the symmetry, right? So we are going with the sentinel as well, accordingly with the this one separators. We went with this one, right? Dollar. This is fine. So the transforming the string with separators, we will be making use of the symmetry, or we have made use of the symmetry or use symmetry and expand only when needed, right? Expand only when needed, right? So this results in the this one efficient. This will be efficient basically to find the longest palindrome and linear time, right? So overall complexity would lead to big of n rather than the big of n square, right? So in many of the lead code contests, if you are giving whether if it is really this one, based on the, if the problem is based on the this one longest palindromic substring, and if the constraints are tight and if you want to go with a big of n time, in that case you can just go with a this one Manacher's algo. I have forgotten this algorithm. Usually, some algorithms are usually taught in the college. Now I don't know this one. Basically, usually Manacher's algorithm, Robin Cup, these algorithms, I believe they are taught in the colleges as well, right? Some of the very important string algorithms. I don't know. I'm just taking a guess. So we are done with the Manacher's algorithm, right? So this is fine, man. Now, so next we'll be discussing on the suffix array construction along with the Casais LCP, right? So when I say Casais LCP, so this one is pronounced as this one, Casais LCP. LCP is nothing but this one, longest common prefix, right? So let me delete this one. This is not related to this particular video. So let me delete this one. Next, we'll be discussing on the suffix array construction along with the concise LCP, right? For now, we have successfully discussed this one, Manacher's algorithm along with the code, right? So we're done with the Manacher's algorithm. For now, this is it. Thanks for watching, guys.